Hello everyone, this is Robert Guderian, as you may have expected. Today we are talking about functions, as you also may have expected. And as I mentioned last lecture, we're going to talk about parameters and arguments, and I will probably misuse those terms, and there's a slide about that. But the idea here is that these functions that I've written so far aren't very useful. They do one thing, and they do it well. We wanted that, but they're inflexible. What we want is to be able to pass an argument to say, do something with this piece of work. What is the square root of 9? Not a function that is going to be called sqrt9 and it always returns 3. That's stupid. That's not scalable. What we want is a generic function that will always work given some arguments. So we want to pass data into our functions. These are called arguments. And then our functions, well, we're going to put something in these brackets. So if we're just looking at this, and in fact, I'm going to copy this out and paste it over here, and boom, on its own, this should work. And it should be obvious what this function does. There's a base, there's an exponent, it takes base to the power of exponent and returns that. Is this interesting code? Not really, but we know how it works and we can see that it's generic. It will work for any integer that is a base, any exponent that is an exponent, and we'll run this math and return us a answer. And it'll always work, and it's general. What we want here is general. An important thing here is, from the slide that I just jumped off of, this x. This x only lives inside of this function. So from the slide, I said power of 2 to the power of 3. Woohoo! Print x, because that's my answer, right? Okay, well, you can see there's an x there. It's unhappy with me. X is not defined. X's scope is only within this indentation group, this code paragraph. That is called scope. And it's a very important concept because we're terrible at naming variables. I have it on good authority. I had an easier time naming my children than I do naming my variables. That sounds crazy, right? But even this one, this is a crummy variable name, x. If this was written well, I would have just said return base to the power of exponent. But I wanted to show you that x only lives here. This should be the power, right? And then I can return the power. And what if I had used this variable name in a different function? Well, we don't want these functions to interact. These functions are all different ideas, and they are all doing their idea well. So say that I'm going to get rid of this stupid joke, which I'm sure you laughed about. It was the best joke you've heard all day. I'm going to have def add. I'm going to add x and y. Now, the question is this the same x as above? Well, no, it's definitely not. This x is set from whenever I pass it. So if I run this, it's still going to yell at me, but I believe I can still use add and then pass 3 and 6, and oh, it gave me 9. Wow, it added for me. I'm so proud. When I passed in 3, this x got set to 3. So that is what these functions do. This x is completely different than this x, and these get passed in order. And I'm going to get rid of this broken stuff. Print add 3 and 6. Why is that an important number to me? Oh, I guess I'm 36. That's why. This is going to get passed in as x. This will get passed in as y. So it'll always go in order. Our arguments will get set to our parameters in order. And that is how it works. So now, this is the pedantic part. You pass an argument to a function, you have a set of parameters in your function. So if you're looking at your code in isolation, there's no arguments, there's just parameters. I have some parameters that somebody else is going to set by calling my function and passing it arguments. So when I'm calling this function, I'm passing arguments 3 and 6. That will set my parameters to 3 and 6, and then I'll add 3 and 6, and indeed return 9. It's kind of easy. It's kind of elegant. We can have any number of arguments. There's actually other ways to pass arguments to functions. This is how we're showing you in this class. This is common to all programming languages because we're trying to not keep this a Python course. This should be a general course. So we have some interesting code. We have this x. It's back. And we have base and an exponent. We're setting our exponent to 10 and it says print power 2. Well, I just told you something about scope, right? X only lives inside of this function. But what about exponent? Scope is important. That's the... Well, let's see. Save. It's unhappy because I have two methods named power. I don't blame it. I didn't have to read that error message. Oop, I can even show you my code. And, oh, it worked. Did we just find some kind of cheat code where we don't have to have arguments anymore? Our methods will never have parameters and everything's going to be great? No, this is actually a terrible idea. What we're doing there is having a good scope problem, but a really bad scope problem. Functions can see all variables that are at the parent tab level. So this, what I've called a main line, this is the least indented code in our program. That's our main line. All of our functions are inside that tab level, aren't they? So they can see the parent tab level. These are called global variables, and they're a terrible idea. It ruins the modularity of our functions. So what did you learn last class? Well, I harped on functions should do one thing and they should do it well. We should be able to see this in isolation and it should make sense. And this one does. We look at this one in isolation and exponent might not be set. So what if our programmer down in our main line, which is probably a future version of ourselves, but they still exist. Oh, now we already have an error saying undefined name exponent. That's because this doesn't work in isolation. This requires something outside of its own scope. And that's kind of terrible. That'd be like me in this class. This class should be something visible onto itself. Now, if I said, we're going to use Ohm's law, and I'm just going to assume you know what that means, and do this. Well, you can look up Ohm's law. That's something that's within your power. Is it fair to you? Not really. And it's not fair to these functions to have expectations outside of themselves. Functions should know everything they need to know and be able to run in isolation. This will cause wildly confusing code. It's a terrible idea. These all are called global variables, and they're bad. The only time you might use this and have me not bite your head off is if you add a constant. Constants are constant, would you believe? Where you'd have pi is equal to 3.14159. That's all I got. And then all these functions can see pi, and that's maybe okay. Pi will never change, so you can rely on it. But it's still dangerous. Can we change them? Yes. Skip the video ahead 10 seconds if you don't want to see something you're not allowed to do in this class. So I'm going to make exponent reappear. Oh, let's actually change pi. So in here, I'm going to say pi is equal to 3, the engineering pi, as it's called. And it says, local variable pi is assigned to but never used. Okay, so this will actually create a new variable named pi, which is okay. Now if I say global pi, I now have a true global variable, and now I will change the value of pi in the entire globe to be equal to 3. I hate it. I feel dirty for doing it. I'll flog myself later. This is almost exclusively a bad programming choice. It is unacceptable in this class because there's no time in this class that you should do that. Sometimes you're forced into it, but you can do that when you're getting paid good money to write bad code, and that's okay. Always use parameters. You need a very compelling case to use a global. Whew. What can we pass in as an argument? Anything. I have not met a limitation here. We can pass in, like when we say open a file name and set that to my file is what I usually do. That is called a file pointer. You can pass that in as an argument. That'd be fine. Ints, floats, strings, objects, lists, dictionaries, sets, anything you've seen can work, which is cool. But of course, they're handled differently. That is for next time because that is a big, nasty thing. But for now, we can know that functions have arguments and parameters, and they map one-to-one. And there's something that I didn't show you, which is what if I say print add and pass it too many. I have too many arguments and not enough parameters. That doesn't work. These will always map up one-to-one in order. Add xy, x will be set to 3, 6 will be set to y, and then we can go. I'll have a bigger example of programming with these parameters in an example video that is posted beside this one. For now, we just know that we can pass in data, and we can work with that data and return a meaningful result, which is quite a beautiful thing, actually. Have a good day.